What if I told you that everything that has ever happened, your first birthday, the dinosaurs, the formation of the stars, is not gone, but is still out there, frozen in the fabric of space-time, as real as this moment right now? That's not poetry, that's physics. Welcome to the channel, where we take the universe's strangest secrets and make them click. I'm glad you're here. Now stick with me till the end of this video, because this idea is one of those things that sound simple, until it quietly rewires how you see reality itself. And if that sounds like your kind of thing, hit subscribe, because this is exactly what we do here. Let me ask you something simple. What's happening right now? You might say, well, I'm watching this video. Maybe you're sitting in a chair. Maybe it's raining outside. Fair enough. But here's where it gets interesting. What's happening right now on the surface of the sun? What's happening right now on a planet orbiting some distant star 40 light years away? You'd probably say, the same now, the same moment, just far away. And that feels completely reasonable. That's how we live. That's how we talk. We plan meetings, set clocks, synchronize calendars, all because we assume that now is a universal thing. A single, shared, cosmic moment that everyone and everything participates in simultaneously. But here's the thing. That assumption is wrong. Not wrong like a rounding error. Wrong like a fundamental misunderstanding of how time actually works. Let's do a thought experiment. Imagine you're standing in the middle of a long, perfectly straight train carriage. Lightning strikes both ends of the carriage at the same time. At least that's how it looks to you. You're in the middle. The light from both strikes reaches you simultaneously, and you conclude those two events happened at the same moment. Now imagine someone standing on the platform watching the train go by. From their perspective, the train is moving. The light from the front strike has to travel a little less distance to reach you because you're moving toward it, and the light from the rear strike has to travel a little more. So from the platform, those two lightning strikes did not happen at the same time. One came first. Same two events, same universe. Two completely valid observers, and they disagree about simultaneity. This isn't a trick. It isn't an illusion caused by signal delay that you could correct for with better instruments. Einstein showed us that this disagreement is real. It's built into the structure of space-time itself. Simultaneity, the idea that two things happen at the same moment, is not absolute. It depends on who's asking and how they're moving. Now let's slow down and feel the weight of that. If I'm moving relative to you, even at walking speed in principle, then the events I call right now across the universe are slightly different from the events you call right now. Not dramatically different in everyday life because we all move at speeds that are tiny compared to the speed of light. But in principle, fundamentally, your now and my now are not the same slice of the universe. There's a beautiful way physicists talk about this. They call it the relativity of simultaneity. And what it tells us is that the universe doesn't come pre-sliced into neat layers called past, present, and future that everyone agrees on. Instead, how you slice space-time into moments depends on your state of motion. Think of a loaf of bread. The whole loaf exists, all of it, the full structure. But depending on the angle you hold the knife, you get different slices. The loaf doesn't change, only the slices do. Space-time is something like that loaf, all of it. Every event, every moment exists as a four-dimensional structure. And what you call now is just the particular slice your motion carves out of it. So where does that leave us? Well, it leaves us with a rather strange and wonderful conclusion. If there is no universal now, if the present moment is not a cosmic absolute but something observer-dependent, then the neat division we carry around in our heads, this clean line separating what exists from what no longer exists, starts to look very shaky indeed. If your now and my now are different and both are equally valid, then what exactly is it that exists? Just your slice? Just mine? Or perhaps all of it? That is the question that pulls us toward the block universe, and that's exactly where we're going next. Because once you let go of the idea that now is special, once you really sit with that, the possibility that the past still exists stops sounding like philosophy. It starts sounding like physics. All right, so we've established something quietly unsettling. There is no universal now. The present moment, that thing you feel so certain about, the thing you're experiencing right this second, is not a cosmic fact that the whole universe agrees on. It's personal. It's observer-dependent. It shifts with motion. So if now isn't fixed, what is? That's the question that leads us somewhere remarkable. It leads us to a picture of reality that Einstein's relativity essentially forces upon us. A picture so strange, and yet so geometrically clean that once you see it, you can't quite unsee it. It's called the block universe. Let's build it from scratch. You already know 3 dimensions of space, up and down, left and right, forward and backward. Every object, every location can be described using those 3 coordinates. Simple enough. Now here's what relativity asks us to do. Take time and treat it as a 4th dimension. Not metaphorically, not as a poetic flourish. Literally, mathematically, treat time as a dimension woven together with the 3 dimensions of space into a single 4-dimensional fabric. Physicists call this fabric spacetime. And here's the key insight. In spacetime, events don't just have a location in space. They have a location in space and time together. Your birth happened at a particular place, yes, but also at a particular when. That combination, that 4-dimensional address, is called an event, and events in the block universe are fixed points in the fabric of space-time. They don't move, they don't disappear, they simply are, the way a point on a map simply is, regardless of whether you're looking at it. Now here's where the analogy really earns its keep. Think about a novel, a physical book sitting on a shelf. Every scene in that book exists simultaneously. Chapter 1, Chapter 10, the final page. The reader moves through it sequentially, experiencing it moment by moment, but the book itself contains all of it at once. The ending exists while you're still reading the beginning. The characters' futures are already written while you're watching their pasts unfold. The block universe says the universe is something like that book. Every event that has ever happened, every moment that will ever happen, your childhood, this present second, events 1,000 years from now, all of it exists, laid out across the 4-dimensional structure of space-time. We, as conscious beings, move through it. We experience it sequentially. We feel the flow of time. But the flowing is something we do, not something the universe does. The universe in this picture doesn't flow anywhere. It just is. Hermann Minkowski, Einstein's old mathematics professor, put it beautifully when he said, "Henceforth, space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality. That union is space-time, and the reality it preserves is not a shifting, evolving present. It's a complete, static, 4-dimensional structure containing every moment that ever was or will be." Now, I want to be careful here, because this is where people sometimes get the wrong impression. The block universe doesn't mean nothing changes. Change is real. It's just that in the block universe, change is a pattern across space-time, not an alteration of space-time. The difference between a caterpillar and a butterfly is encoded in space-time as 2 different events at 2 different times. Both exist. The transformation between them is a shape in 4 dimensions. And this is where the original question, why does the past still exist, begins to get a precise physical answer. In the block universe, the past doesn't disappear when we stop experiencing it, any more than the city of Rome disappears when you leave it. It remains there, at its coordinates in space-time, fixed, permanent, real. The moment you were born, the first stars igniting in the early universe, the last words someone you loved ever spoke, none of it is gone. It exists at its location in the 4-dimensional structure of space-time, as real as any place you've never visited but know is still there. We don't go back, but that doesn't mean it's not there. And to understand why we can't go back, why time feels like a one-way street even in a block universe where past and future both exist, we need to talk about something called the light cone. That's where we're headed next. So we have this block universe, this 4-dimensional structure where every event, past, present, future, exists as a fixed point in space-time. Beautiful, geometrically clean, philosophically staggering. But here's the question that naturally follows. If all of space-time exists, if the past is really there, encoded in the fabric of the universe, then why can't we reach it? Why can't we send a signal back? Why does it feel so permanently, so absolutely gone? The answer lives in one of the most elegant structures in all of physics, the light cone. Let's draw a picture in our minds. Imagine you're standing at a single point in space-time, right here, right now, this moment, this event. Now imagine drawing a map of every event in the universe that could possibly influence you, or that you could possibly influence. Here's the constraint. Nothing travels faster than light. That's not an engineering limitation. It's a law woven into the structure of space-time itself. Information, energy, matter, causation, all of it is speed limited by c, the speed of light. So from where you stand right now, draw a cone spreading upward into the future. representing every event you could possibly reach by sending light or traveling or throwing something. That's your future light cone. Everything inside it is reachable. Everything outside it is forever beyond your causal influence. Now draw another cone spreading downward into the past. That cone captures every event that could possibly have sent information to reach you right now. Every cause that could have contributed to this present moment. That's your past light cone. Together, these two cones, one reaching into the future, one anchored in the past, form your light cone. And everything outside both cones, physicists call that the elsewhere. Events so far away in space or so close in time that not even light has had time to bridge the gap. Those events cannot affect you. You cannot affect them. They are causally disconnected from this moment entirely. Now here's what this means for the past. Every event in your past light cone is locked in, causally sealed. The signals from those events have already arrived, or they're still traveling toward you right now. The light leaving a star 40 light years away that you'll see tonight actually left that star 40 years ago. You're not seeing the star as it is. You're seeing it as it was. You're looking directly into the past every time you look at the night sky. And here's the thing. That light, that information, that causal fingerprint, it didn't come from nothing. It came from a real event. A real moment that happened, was encoded in the fabric of space-time, and sent its ripples forward through time toward you. The past, in this sense, is not merely a memory. It is causally active. It is still reaching you. Let me give you an analogy that might make this viscerally clear. Imagine dropping a stone into a perfectly still pond. Ripples spread outward in all directions. Now you can't unsend those ripples. They are moving through the water whether you like it or not. Someone standing at the edge of the pond, far enough away, hasn't felt them yet, but the ripples are coming. The event of the stone hitting the water is, in a very real sense, still unfolding its consequences forward through time. Space-time works the same way. Every event sends its causal ripples forward through the light cone. The Big Bang itself is still reaching us. We can detect it as the cosmic microwave background radiation, the faint thermal afterglow of the universe's first moments, arriving at our telescopes right now, nearly 14 billion years later. The past is not silent. It is speaking. We just have to know how to listen. But here's the quietly profound part. The light cone doesn't just tell us what we can receive from the past. It tells us why the past is unreachable in the other direction. You cannot send a signal backward through your past light cone. You cannot reach out and touch an earlier event. Not because the event isn't there. Remember, in the block universe, it absolutely is. But because causation only flows in one direction through the light cone structure. The geometry of space-time permits influence to travel forward, never backward. The past light cone is a one-way membrane. You can receive from it. You cannot return to it, which raises a beautiful and slightly haunting question. If the past exists, fixed, real, permanent in the block universe, and if we can still receive its signals, still feel its causal fingerprints, then why does it feel so irreversibly gone? Why do we remember yesterday, but not tomorrow? Why does time feel like it has a direction at all? That, it turns out, is not a question about space-time geometry. That's a question about entropy. And that's exactly where we're going next. Here's something that should bother you. The equations of physics, the fundamental laws that govern how particles move, how fields evolve, how forces act, almost all of them work equally well in both directions of time. Run a film of two billiard balls colliding and reverse it. Does it look wrong? Not really. The reversed collision obeys the same physical laws as the forward one. Run a film of planets orbiting a star and reverse it. Still perfectly valid physics. The equations don't care which way time flows. They're symmetric. So here's the puzzle. If the laws of physics have no preferred direction of time, if the mathematics works just as cleanly forward as backward, then why do we experience time as having a direction at all? Why do we remember the past but not the future? Why does a dropped egg shatter on the floor and never spontaneously reassemble itself? Why does a warm cup of coffee cool down but never spontaneously heat back up? Something is breaking the symmetry, and that something has a name. It's called entropy. Let's build this idea carefully, because it's one of those concepts that sounds technical, but is actually deeply intuitive once you see it clearly. Entropy at its heart is a measure of disorder, or more precisely, a measure of how many different microscopic arrangements of a system are consistent with what you observe at the large scale. Here's the key thought experiment. Imagine you have a box divided in half by a partition. On one side, you put a gas, a billion tiny molecules all crowded together. On the other side, nothing, a vacuum. Now you remove the partition. What happens? The gas spreads out. Every time, without exception. The molecules fill the whole box, and they never spontaneously crowd back to one side. Why? Not because some force is pushing them outward, but because there are vastly more ways for the molecules to be spread throughout the box than there are ways for them to be crowded into one half. If each molecule's position is essentially random, the overwhelming probability is that you'll find them spread out. The crowded state is not impossible. It's just so improbable that in the age of the universe you would never see it happen by chance. Entropy increases because the universe is, in a sense, exploring possibilities, and there are always far more disordered possibilities than ordered ones. Now here's where time enters the picture. The second law of thermodynamics tells us that in any isolated system, entropy tends to increase over time. Disorder grows. Ordered, low-entropy states evolve into disordered, high-entropy states. And crucially, this process is irreversible in practice, even if not in strict mathematical principle. This is the arrow of time, not a feature of the geometry of space-time. As we saw, the block universe itself has no preferred direction, but a feature of thermodynamics, of probability, of the overwhelming statistical tendency of complex systems to move from order toward disorder. Think about that broken egg again. The moment before it hits the floor, you have a highly ordered, low-entropy system, a smooth, intact shell, yolk neatly contained. The moment after, you have a high-entropy mess, fragments, splatter, 100,000 possible arrangements of shell and yolk on the floor. The laws of physics would permit the reverse, all those fragments spontaneously assembling into a perfect egg. But the probability of it happening is so vanishingly small that it effectively never occurs. The direction from intact egg to broken egg is the direction of increasing entropy, and that, at its deepest level, is what we mean by forward in time. But now here's the part that truly pulls the rug out. If entropy defines the arrow of time, if the future is simply the direction in which entropy increases, then we have to ask, why was entropy so low to begin with? Why did the universe start in such an extraordinarily ordered, low-entropy state? The Big Bang wasn't a chaotic explosion in the conventional sense. It was, thermodynamically speaking, remarkably ordered, smooth, uniform, low entropy, and it has been moving toward higher entropy, toward greater disorder, greater complexity, greater structure, ever since. That initial low entropy is the ultimate reason time has a direction, not something built into the laws of physics themselves, but something baked into the initial conditions of the universe. And memory, the reason you remember yesterday but not tomorrow, is a direct consequence of this. To form a memory is to create a record, a low-entropy imprint of a past event. Your brain, your photographs, your written notes, all of them are ordered, low-entropy structures that causally trace back to earlier moments. They are entropy's fingerprints pointing backward through time. You remember the past because the past left marks. The future hasn't happened yet, so it hasn't left any. So where does this leave us? We have a block universe, a four-dimensional structure where past, present, and future all exist. We have a light cone, telling us that the past is causally sealed, still sending its signals forward. And now we have entropy, explaining why, within that timeless structure, we experience a direction, why it feels like we're moving from somewhere to somewhere. The past exists. It is fixed in space-time. It shaped everything that came after it, and we remember it, precisely because it was ordered enough to leave a trace. Now it's time to bring all of this together, because what does it actually mean for how we live, for how we think about loss and memory and impermanence, that the past still exists? That's the question we'll sit with in the final section. Let's take a breath, because we've covered a lot of ground together, and before we go any further, I want to make sure we feel the full weight of where we've arrived. We started with something that felt obvious, the present moment, now, and we discovered it isn't universal. It shifts with motion. Your now and my now are not the same slice of the universe. Simultaneity is relative. That led us to the block universe, Einstein's space-time, where every event that has ever happened or will ever happen exists as a fixed coordinate in a four-dimensional structure, not becoming, not passing, simply being. Then we found the light cone, the causal boundary that explains why the past, though real and fixed in space-time, cannot be revisited. Information flows forward, causation flows forward. The past light cone is a one-way membrane. You can receive from it, but you cannot return to it. And then entropy, the thermodynamic arrow that explains why, inside a timeless block universe, we experience a direction. Why we remember yesterday. Why broken eggs don't reassemble. Why the universe, born in extraordinary order, has been moving toward complexity and disorder ever since. Now we bring it all together. Here is the picture that physics paints, as honestly and carefully as I can render it. The past exists. Not as memory, not as record, not as trace, though it leaves all of those things, but as a real, fixed region of space-time. The moment you were born occupies a specific set of coordinates in the four-dimensional fabric of the universe. It is there. It will always be there. It cannot be altered, cannot be erased, cannot be unmade. Think of a river, but a frozen one. Imagine the entire river, from its source in the mountains to its mouth at the sea, frozen solid. Every ripple, every eddy, every current, all of it locked in ice, perfectly preserved. A fish that once swam upstream is still there, fixed in the ice, at the exact position it occupied at the exact moment the river froze. That is space-time. That frozen river is the block universe, and we are, all of us, like a light moving along the surface of that ice, illuminating one cross-section at a time, experiencing it as flow, as motion, as now. But the river itself is not flowing. It is not becoming. It simply is, in its entirety, all at once. Every moment you have ever lived is frozen in that river, still there. Perfectly real. Now, I want to be honest with you here because good physics demands honesty. The block universe is not the only interpretation consistent with relativity. Some physicists prefer the growing block, where the past and present exist, but the future is genuinely open, genuinely unwritten. Others prefer presentism, the view that only the present moment is real, and that relativity's challenge to simultaneity must be resolved some other way. These are serious positions, held by serious people. The physics does not force us to the block universe with absolute certainty. What it does force us to confront is that our ordinary intuitive picture of time, a flowing river carrying us from a real past through a real present into an open future, is almost certainly incomplete. Something about time is stranger than it appears. Physics has earned that conclusion many times over, but here's what I find quietly extraordinary about all of this. If the past really does exist, if it is fixed and real in the fabric of space-time, then nothing is ever truly lost. Every act of kindness you have ever performed exists permanently in the structure of the universe. Every moment of genuine connection, every experience of beauty, every instance of courage or love or curiosity, all of it is there, sealed into space-time, as real as any physical object. The conversation you had with someone you've lost, the afternoon when everything felt exactly right, the moment a child first laughed. Physics says those moments are not gone. They are there, at their coordinates in the frozen river, as permanent and as real as the laws that govern the stars. We cannot return to them. Entropy and the light cone see to that, but their existence is not contingent on our remembering them. They do not require our attention to remain real. They simply are. There's a certain kind of peace in that, I think. Not the peace of nostalgia, not the peace of wishful thinking, but the peace of understanding. The quiet, solid comfort of knowing that the universe keeps its records perfectly, that what happened happened, that the good that was done was really done and remains done forever. That is what physics tells us, and I think that's worth knowing. And that's the full picture. We began with a question that felt almost too simple to take seriously. Does the past still exist? And we ended somewhere that I hope feels genuinely surprising. Not because we wandered into philosophy or speculation, but because we followed the physics, carefully, honestly, all the way to its conclusion. We found that now is not universal. That space-time is a four-dimensional structure where every event is a fixed, permanent coordinate. That the light cone seals the past causally, not by erasing it, but by making it unreachable. That entropy gives time its direction, its arrow, its feeling of flow, and that the past, in the most precise physical sense we have, is not gone. It is there, frozen in the fabric of the universe, real, permanent, and untouchable. Now, I want to leave you with one thought. Science is sometimes accused of making the world feel smaller, of draining mystery out of things by explaining them. I've never believed that, and I hope this video is a small piece of evidence against it. Because what we've done today is look at time, this thing you live inside every waking second of your life, and discovered that it is stranger, richer, and more permanent than you ever imagined. The universe is not a place where things happen and then vanish. It is a place where things happen and remain, where the past is not a ghost, it is a fact. That, to me, is not a smaller world. That is a larger one. If this video gave you something to think about, if it shifted something even slightly in how you see time, or memory, or the permanence of moments, then it did exactly what it was supposed to do. Hit the like button if you enjoyed it. It genuinely helps more curious people find this content. Subscribe if you want to keep going deeper, because we are just getting started. The universe has no shortage of beautiful, unsettling, clarifying ideas, and this channel exists to work through them together, carefully and honestly, one concept at a time. And if you have a question, something that's nagging at you, something that didn't quite click, or something this video made you wonder about, leave it in the comments. I read them, and the best questions sometimes become the next video. Thank you for watching, thank you for thinking, and I'll see you in the next one.